My name is Rachel Julian. I'm going to go ahead and provide the published version of my presentation so that way you can follow along with me today. I have several links that I would like you to click on to allow for feedback. But I would like to go ahead and share that if you have questions, please feel free to interrupt me while I'm presenting. Feel free to turn off your mic and ask your questions right away. I would like that to occur so that way I can answer anything immediately before I continue on teaching the content. So if y'all want to go ahead and turn off your mic and say hello or say good morning in the chat. Thank you for being here today. I just provided the published version of my presentation. I will provide at the end the link to the view only. Therefore, you can take it and use it as you like. So it's officially 9:31. So at this time, I'm going to go ahead and share my screen and get started. Before I get started, does anyone have any questions? And feel free to turn off your mic or ask those in the chat. Okay, let's go ahead and get started. So today's session is Imagine, Tinker, Design, Create. I am a digital learning specialist with Brunswick County Schools on the coast. A lot of what I am presenting today, I have used directly with teachers in the county. So I do have a lot of hands-on experience. But before I get started, I just need to remind everybody, please download the Performance Matters app. You will use that today to scan a QR code at the end of the presentation, so that way you can get credit for today's session. And if you need that app, the link is right here with the how-to page. The registration code is also provided. So I like to start off my sessions with brain breaks because it's early in the morning, it's the summertime. Some of you have attended already an 8 o'clock session this morning. Some of you, are just getting to work or starting your day. So I would like to go ahead and allow you all a couple of minutes to do one of the brain breaks. If you'd like to do all three, feel free to do so. But I have included here a cross-body exercise, stretch it out or open your chest. All three of these, especially the open your chest, is great for you if you are sitting at a computer all day long, much like I do some days. So I'm going to give you a couple of minutes to please go ahead and do the brain break. Okay, so hopefully everybody's had a moment to do their brain break exercise. Does anyone have any questions? Can everyone see my screen in entirety? I just want to get some feedback there. Can everyone see my screen? All right, so the session abstract and DLC alignment for today. Our role as educators is to prepare students for life outside the classroom. Currently, we are trying to get students creating and using problem-solving strategies. So tinkering and 3D printing falls right in those categories. We need to teach students to implement the engineering design process so that way they can identify problems, design and create solutions, test, redesign, and then test again. So our learning targets for today are, We will learn the meaning of 3D printing and how it's used in the classroom. We will learn the engineering design process and how to incorporate within STEAM projects. We will learn how to use and implement Tinkercad, Thingiverse, and MakerBot Print, and we will learn how to set up a MakerBot Print sketch printer and how to print 3D projects. So, if you will, I would like you all to click on this link. I'd like you to tell me what you know about the learning targets at this time. So what this is a Jamboard that I've incorporated. I have placed the learning targets here. You do have editing access. So I would like you just pick a frame and share some information about what you currently know about 3D printing, about the engineering design process, or if you've incorporated STEAM projects. Share some information on any of the frames, and then we'll look at those in just a moment. So those of you that just came in, I have provided the link to the published link to my presentation in chat. If you're having issues getting to that, please let me know. And we are on slide number 6, and we are on a Jamboard, and you're just sharing some information with me about what you know about the learning targets. If you know anything, if you've incorporated the meaning of 3D printing, if you've incorporated, you know, the engineering design process with students, STEAM projects with students, can everybody get to that Jamboard and edit? I just want to confirm that you all can edit. And if you just want to turn off your mics and let me know, or can you resend the link? I, of course, can. Yes. Okay, so there's that link again. You are very welcome. So if anybody, I just want to make sure you can get on those frames and share some info. I see here, I don't know very much. I would like to see how I can add the 3D printer into the 6th grade social studies class. Oh, yes. With social studies, there's lots and lots of ideas that we can incorporate based on the standards that you're covering. I love using Tinkercad and Thingiverse. Wonderful. Okay, so you have a Dremel. Okay, so in our county, we have MakerBot, MakerBots, and we have different versions of MakerBots. So that's what the perspective I'm coming from. I teach K-5 STEM using the ED. Okay, thank you for sharing. Please share what you know. Okay, I do not know anything about 3D printers. Okay, but you would, okay, so art teachers, you are going to love the 3D printer. So I'm gonna share a lot, and I've worked with a lot of art teachers with incorporating 3D printing, so I will definitely share some ideas with you when we get to that slide. Okay, let's see if anybody else familiar with, I wrote and earned a grant to purchase 3D printers for school. I have 2 decades. Okay, wonderful. All right, so I'm hearing that we have quite a bit 3D printers in our buildings. Okay, that's wonderful. So we're looking for some strategies to incorporate them. Okay, so I'm going to head back to the main presentation now. And what I've done here is I have created 6 mini presentations within this one presentation. And so each of these links are to the published versions. I'm going to guide you through, but again, at the end, I will give you a view only of the entire presentation. So let's get started with what is 3D printing. And I'm hearing that a lot of you have 3D printers, but I just want to make sure everybody knows what they are. So what a 3D printer does is it takes a 2-dimensional or flat design and it prints it in 3D using something called filament. And filament is a type of plastic, and there's different types of plastic, but it uses a .obj file or a .stl file to read that information from the MakerBot print or your prep software, and it takes it and it prints it using that filament to where it's a three-dimensional item. So filament options, you've got PLA, you've got ABS, you've got nylon. There are other types of filament other than these three. I will tell you, I have the most experience with PLA simply because I feel like it's the easiest to use. It's also a little bit cheaper, so it's great for testing, creating designs, bringing it into the classroom, allowing students to print and then redesign and then print again. It's not going to cost you an arm and a leg. So here, it's very important with 3D printing, before you have your students actually 3D print, they need to understand what 3D printing is, and they need to understand the vocabulary behind it. So I have created here a 3D printing vocabulary deck with images and vocabulary definitions. And I would utilize this. I would bring this in and explain what an extruder is. Definitely let them know that that's the device within your printer that's going to extrude the filament and melt it, so that way it can build and create that 3D item. They definitely need to know what a build plate is. That is what the filament draws onto and what the design rests on and dries on before you pop it off. They need to know what filament is and how to load a 3D printer, depending on the grade level that you are incorporating this. Infill, which incorporates the support structure. So if you don't incorporate a lot of infill, your design could be kind of flimsy. So you need to make sure that you provide enough infill to support whatever you're printing and whatever its function is serving as. Slicing is the ability to take that 2D model and make it into 3D. So a 3D prep software such as MakerBot Print, I'm going to show you, that's what it does, is it slices the design, it preps it for the 3D printer, and it changes the file format. You got a gantry that moves your extruder back and forth, so that way it can travel along the X and Y axis and draw your design. You also have the ability with a 3D printer for it to draw along the Z axis, which is up and down. So if you are printing something that is going to be very tall, you're going to watch your extruder go up and down vertically. And then you've got your carriage that holds the extruder. What a purge line is going to be that little piece of filament that comes out first, and it shows you that your extruder is working properly. So you want to always draw a purge line to make sure that everything's okay with your printer before you spend a lot of time actually trying to print. You've got a bridge, which are unsupported sections of a print. You need to be careful about trying to print those without support. So you want to build in some support. You also have overhangs, and those are pieces that kind of jut out. Rafts, every single time I print, I incorporate a raft. And that raft, it creates support for whatever you're printing, and then it just simply pops off. And so you're going to definitely want to incorporate that raft at the bottom. It just supports your creation, and then it pops off at the end. You've got shells. Again, that provides support as well. You've got your layer height, which is the height of each layer of a printed item. So sometimes you want layers to be very small, so that way it appears that the design is fluid and you can't see the individual lines of print that are occurring. You can sand filament, you can paint filament. So if you were to print a vase, for instance, you could sand that, you could paint it, and it could appear as if it was never 3D printed, like you bought it in the store. This is an example of some support material. On the left, you see the support material here. Sometimes you do have to file that off and kind of chip it away. Most of the time it comes off pretty easily, but I have seen teachers have to sand it a bit. This just explains what STL file is, and it's a way for the computer to read that 3D print, and it's titled Standard Tessellation Language. And then we've got Thingiverse. I'll go into Thingiverse a little bit. I'll go into Tinkercad a little bit, as well as MakerBot Print. What CAD means in general is computer aided. So that's why it's called Tinkercad, because you're tinkering in a computer aided drawing software. And that's why I use that software, because it's web-based, it's free, and it's easy for teachers to set up a classroom. And I'll go into that more in just a bit. You've got your scale. You need to make sure that your surface is watertight, so you don't want to have gaps and holes unless they serve a specific purpose. Print orientation, I'll get into that when we talk about MakerBot Print. Tolerance, if you're printing a container and it has a lid, you need to create a little bit of space, a few millimeters along the outside edge of the bottom, so that way the top can slide within it. So you need to give a little bit of give. You don't want to print it where it's not going to actually slide on the top. So that's our main vocabulary when we are talking about 3D printing. Does anyone have any questions at this time? Is everybody feeling okay about that? And feel free to take that deck and utilize it with your students. All right, so I've also created a bingo 3D printing vocabulary game. So you can incorporate this to help your students learn those vocabulary words. It's just kind of a fun way to get them to remember prior to printing. Feel free to print and use as you like. I've created this little slide that allows you to give this to your students. That's just how you can take your Tinkercad file and then export it to a Chromebook. And feel free to provide those to your students. I created also a 3D printing design analysis checkout. And this is something your students need to go through prior to actually printing. And so they need to double check all these things. You know, depending on the grade level that you're teaching, I would say this is more geared towards upper middle high school. With the younger students, you need to walk through these items with them and assist them. And then we have a 3D printing challenge rubric, and it does force a copy for you. But again, what this does is it's a way for you to assess their prototype, their build. So feel free to take that as well. A STEAM challenge template. This was created, we use this heavily within our school system. This STEAM challenge Jamboard template, it guides students through the engineering design process and allows them to prep to actually create in Tinkercad. So feel free to click on those 3 dots and make your own copy and use that within your school system. So I would like you to share your thoughts. I have created sharing feedback within Mentimeter. And so I'd like you to click on this link, share your thoughts, and then I'm going to open up the view results here. And I want to see what everybody is saying. Oh, okay. I've already got quite a bit of feedback here. To make 3D first scale. Okay. All right, so I'm seeing with the visual arts, 3D animation, pottery. Okay. Now, I do see here where someone has discussed being time consuming. 3D printing is not necessarily a quick process. It is time intensive, especially if you only have one or two printers and you've got a load of students. So you're going to have to be very careful about the amount of time you allot to a project. You can also print multiple builds on the same work plane and have them print at the same time. The problem with that sometimes you can run into is if your extruder is acting up and it doesn't want to print perfectly, then you could have 3 or 4 builds where you have to start over instead of just one. So you have to analyze what's most important. I also see teachers when they're utilizing projects that they decide upon a handful to actually print, whereas all the students design in Tinkercad, but then the class chooses several to actually print on the 3D printer. I would love to implement 3D design challenges. I love that. So anytime I'm incorporating engineering design process, I like to incorporate an overall challenge question that's pretty open-ended, so that way the students can analyze that challenge question and then solve that problem on their own. So I think that's a great way to get started. With the Chromebooks, yes, absolutely. They could plan or build their 3D structures. They would utilize Tinkercad since it's web-based on the Chromebooks to design, and then they would actually be able to export those STL files. And then there's a variety of ways you could collect it. I've had some teachers create a Google form with the upload question, and then the students upload their STL file to the form, and then the teachers have access to it to then print. So there's a variety of ways to incorporate that, but students can definitely use Chromebooks to plan or to build. And then, with the planning stage, before you even get to Tinkercad, that's why you would want to use that STEAM Jamboard to guide them through the process to make sure that they are taking that challenge question, drawing an idea, addressing what that design is going to solve in the real world. And then it also allows for opportunities to redesign, reprint based on testing it out. Tinkercad seems interesting. Okay, so Tinkercad, I have seen it used in the lower grades. I would start off simple. When you get to Tinkercad, I'll show you, they've got lots of different mini lessons to allow the kids to practice and to learn all the tools. I also created a slide deck that you can give them or show and guide them through learning those steps. So when we get to that point, I'll reiterate that. Is there anything else that you all would like to share? Okay, so thank you for sharing. So let's continue because we have got so much to look at. So let's get into the engineering design process now. Okay, and I'm just going to close out all these little mini tabs here. Okay, so the engineering design process. These are the official steps. Ask, research, imagine, plan, create, test, and then go back and improve after testing. So when you ask, students need to ask questions and identify the need and the constraint. So the need is the solution to the problem that is occurring. So with this challenge question, with this problem that's occurring in real life, they need to identify the problem. They need to figure out what the solution is going to be. The constraints are the limitations that are present when solving the problem. So the students need to identify these. If you're working with the younger grades, you're going to need to guide them through this. If you're working with middle and high school, they're going to be independent enough to figure that out on their own. When it comes to research, the best research comes from professionals in the field. So if you're especially working with upper middle, high school students, have them reach out to professionals and have them ask questions about the problem that's occurring and with the design that they're creating. And then they will learn more about that profession in the meantime. Imagine. So this is where the creativity comes into play. It's going to be hard as an educator for some of us to step back and allow them to really think on their own. I am very guilty of this. I always want to step in and give them pointers or suggestions or say, no, that's not going to work. We need to keep away from that. We need to allow them time to brainstorm. And this can occur, between multiple students. You can have them work in groups on a challenge question. It does not always have to be independently. It could be in pairs if you like, but allowing them time to brainstorm. And this needs to be sufficient time. Don't give them 30 minutes. They might need 2 or 3 days of class time to really think about what they're trying to do with their design. And so I haven't created this, but I'll link this for you, the handout and brainstorming guidelines. So feel free to give this to your students. I did not create this, but these are posters that you can hang up in your classroom. And they do come from the techengineering.org site. All right, then you have to plan. And again, just like brainstorming, the students need ample time to plan, to choose one solution for them to actually build. So they need to revisit the need of the challenge question or problem. They need to revisit the constraints and the research. They need to compare the ideas, and then they need to pick one to move forward with. Again, this might take a couple of days. So make sure you build in that time. Then they need to actually build and create their prototype, and they need to understand what a prototype is. So that's another vocabulary word that you need to train your students on. A prototype is the very first build that's created to be the solution to the problem. So this prototype, they may have to revisit after testing their design. They may have to go back to their prototype, alter it a bit, and then print it again. This is the test. So you would need to print before they test. They need to be able to print that design, test it out, and then they would be able to go back and improve their design. Not every design is going to need to be improved. Sometimes they'll knock it out of the ballpark the first time, but you need to allow for that time to occur in case a design needs to be improved. So why do we need to incorporate STEAM? Well, STEAM represents science, technology, engineering, art, and math. I hear a lot of STEM being incorporated. I feel very strongly that art should be a part of that. Art is focused on creation and creativity, and it teaches the students those specific vocabulary words to help them visually design something to print. So like the elements and principles of art, it's important that the students have that base knowledge before they design something visually. So again, I have that STEAM challenge template printed here, but I also created a Simple Machines Jamboard template. And so with Simple Machines, I use Google Arts and Culture's VR tour. It's the new exhibitions tours on Simple Machines. I use that to teach the kids what a simple machine is, because a lot of students will need to incorporate Simple Machines within their design to solve the problem. So feel free on this Jamboard to come up here to these 3 dots, make a copy, and then use it with your students. So we are back to sharing your thoughts. I would like you to share with me your thoughts on the importance of implementing the engineering design process within STEAM instruction. So why do you feel like it's important to incorporate STEAM, especially when you are utilizing 3D printing projects within your class? All right, so I'm seeing students have ownership of the project. Yes, ownership's so important. If the students do not feel like they have a voice in what they're creating in a choice, they will not feel like they have ownership of what they are doing, and they'll have less of an interest. So it's best to keep these open-ended, allow them to choose the problem, and allow them to solve it on their own. Okay, they need to learn troubleshooting from start to finish. I love the idea of the students figuring it out on their own. Yes. And are there any questions at this time? Feel free to unmute. Everybody doing okay? Just tell me yes in the chat if everyone's doing okay. I just want to make sure that you can get to everything so you can respond or ask questions if you'd like. Okay, good. All right, just checking in there. All right, so let's continue because I have a lot of content to show you. All right, so let's go into Tinkercad. So in chat real quick, who's used Tinkercad before? I want to know. You have. Okay, can you share with me how you utilized Tinkercad? What was the project and the grade level that you used it with? And what type of device you used? Did you all use Chromebooks? I've used it, but I don't use it. Okay. So you've went in and explored it, but your students haven't yet. Okay. I've worked with homeschooling, the basics of design. Okay. Something important to know with Tinkercad, Tinkercad's one of those resources that you really can use in about every subject area, K through 12. You know, with K1, K2, you're going to really have to guide them. But I have seen some students really utilize it well and get very creative with their designs. Ours worked on creating body parts for body systems like the heart. That's wonderful. I love that. And there's different types of filament. There's actually malleable filament that's soft. So when you print something, it can actually be soft and squishy. So you could use that type of filament to print those body parts. So when they touch it, it's soft like an organ. And I use Amazon, honestly. There's all kinds of filament on Amazon. There's filament that looks like copper when you print it, looks like wood. There's glow in the dark filament. There's regular filament that's hard when you print it, but then there's malleable filament that's soft when you print it. There's all different types of filament that you can incorporate. A big thing that you need to make sure, though, is when you choose your filament is the width of the filament. And I believe 1.75 millimeters is the most popular for a lot of printers to take. But like a Lulzbot, I think it takes 3 millimeter filament. So you need to be careful about the type of printer you have and buy the filament that makes the most sense for your printer. Super cool. Ours were hard and kind of fragile. Yes, so definitely, Allison, check out that malleable filament. I think the kids would really enjoy it. All right, so let's go into Tinkercad. The biggest thing with Tinkercad is that it does have the ability for you as a classroom teacher to create a classroom within Tinkercad. I recommend this because you are able to go into each creation the students are working on and monitor their work. You can see all of their work simultaneously. So what you would need to do is go to Tinkercad, create a free account. I use my Google credentials because our county is Google County. We use Gmail, etc. But you would go there and you would click on, I'm already signed in, but you would, let me log out real quick so that way you can see. You would sign in here and then I sign in with my Google account. Now, based on terms of service, you need to be careful about students younger than 13. They do need parent permission unless you're setting up a classroom where you can monitor, where they would join your class with a code and a nickname. But still in that instance, I would still let parents know what you're doing in your classroom just so that way they remain in the loop. So again, Tinkercad is a web-based CAD computer-aided design program. I love it because it's web-based. I love it because it's free. So when you come in here and you create your account, make sure you identify yourself as a teacher. That allows you to create classes. So that's a very important step. So students can get to your class with a class link and a class code. That's the way that I definitely recommend. I put my class link in Google Classroom, and then the class code I also place in there. I also assign seats. So when you assign seats, you need to input the student's name. You could just use their first name, and then it creates an automatic nickname for the child. You can change the nickname to be whatever you want. So if it's easier for you, like I just worked with an art teacher that had 36 kids. What we did is we input the kid's first name, and then we changed the nickname for them to join to like student 1, student 2, student 3, and it made the process a whole lot easier. So I have here linked for you some lesson plans that Tinkercad has already created for you. They actually have a database now. This is kind of new. They didn't used to have this, but I'm glad they added it on. They incorporate, you know, pretty much every subject area you can go into, but I know I have some art teachers in the session. So you can see here some different art templates you can get started with. But again, these are just templates. So your kids can actually build this on their own. They don't necessarily need a template. Here's that letter to parents. I would definitely do this. I would incorporate with the beginning of the year paperwork that you send out and just get those signatures and just make sure they know that you're going to be utilizing Tinkercad within instruction. Tinkercad has a lot of special key buttons and keyboard shortcuts that come in handy if your kids start to learn them. I've seen my middle school and high school students really get to know these keys very quickly based on creating the designs that they are. So this is something you can print for your students. You can print it right here with this link and have it available for them, and also put it in Google Classroom so they have a digital copy. And then a beginner's guide glossary, you know, more vocabulary so that way they understand how to fully work within Tinkercad. So here's some more vocabulary that you can go through. Again, a lot of this is going to be the same vocab that you're working with on a 3D printer, but revisiting that can only help. Okay. So once everyone is in Tinkercad, the very first thing, once your students have joined your class, I would have them go to the Learn section. The Learn section within Tinkercad has starter projects. I believe there's 10. And I would have your students go through these starter projects. I know it can be time consuming, but it's going to save you time in the long run, especially if you plan on incorporating Tinkercad several times throughout the school year, because your students will understand how to use Tinkercad and they'll be more quick at creating than if you were not to incorporate this learn section from the very beginning. So definitely allow them time to go through the lessons. Here's just a hyperlink to that learn section with that icon. These are the slides I was talking about that you could bring up on your smart board or your Boxlight or your Newline or whatever board you have in your classroom. You could bring these slides up to teach the kids all the icons within Tinkercad. And it's very important that they know these right off the bat. Otherwise, it's going to take them a while to create a design. Here's another slide full of vocabulary. How to create a house. So if you click on that icon, you can give that little mini lesson to your kids, and your kids can practice how to create a house. This just shows you some of the different Tinkercad shapes that they can bring in. Tinkercad also has circuits, and it has other types of like coding. They just brought in coding. That's pretty recent. So kids can use Tinkercad not to just design, but they could actually practice circuits in here as well. You can make your build look like Legos. That's also an option. And it's this little button up here that looks like a Lego piece next to the person in the upper right-hand corner. So if you want them to take their design and make it look like Legos, you can click that button and it'll convert it for you. And then here's more vocabulary for your kids. So Thingiverse I haven't talked to you about, but what Thingiverse is a website that has tons and tons of pre-made STL files that have been created by individuals literally all over the world on literally everything. Now, I would not let your kids loose on Thingiverse because they could run into things that are not necessarily appropriate for school. So Thingiverse is going to be something that you use as a guide to find files that you could then bring into Google Classroom, and they can import into Tinkercad to alter the design. It could also be a way for you to find something to show as a visual aid up on the board to get them started. Again, I wouldn't let your kids loose on Thingiverse. I would use it as a teacher as a starting point. How many of y'all are using merge cubes? How many of y'all have ever used merge cubes? Tell me in chat. You do. Okay. Can you tell me how you use merge cubes? So did you know that you can actually create a design in Tinkercad and then export that creation into a merge cube application? And when the kids scan the merge cube that they're holding in their hand using an iPad or a mobile device through the app, their design turns into the merge cube. So that is a great way to allow the kids to hold their designs, but to not actually have to print every single one. So there is a merge cube application you put on a mobile device. You connect your Tinkercad and your merge cube accounts. You pull your design into the merge cube app. Then you scan your merge cube with that application, and your design is then turned into the merge cube. And it's so cool. It's not in color, but the kids can still hold their design and turn it all different ways and see their creation without actually having to print it. So if you've never done that before, I've got the directions right here with this icon, how to export an object to merge cube. And the kids absolutely love it. They go crazy about it. And this is a good way also to look at the design in a real world sense prior to printing, to save yourself some time with printing, to make sure that that design looks good before you actually send it to the printer. All right, so again, I said that you can create circuits in Tinkercad. There's a bunch of different pieces that they can utilize. Again, there's code blocks, which is coding. The kids can code in Tinkercad now. And then these are some different links that are available. I love that Tinkercad creates challenges, and these challenges are available to any students all over the world that want to compete. And then there are winners and there are significant prizes from that. The making starts here. This link takes you to the Autodesk site. Autodesk is actually the company that owns Tinkercad, but there's different lessons for maker spaces on this site. So if you're in need of some makerspace ideas, please look here. And then there's a maker program starter kit for teachers. And so you can actually download this starter kit and print it. It's pretty substantial. It's pretty large, but it guides you through creating maker stations in your classroom or in your school. Okay, so again, I would like you to click on share your thoughts. So with this question, what was your favorite option with Tinkercad and why? That's what you're answering. And if you will, just include some feedback. What was your favorite option with Tinkercad? And that was a very, very quick overview. There is so much to Tinkercad. There is so much you can do and your students can do. It's going to take some time to go in there, but once you do, the kids can utilize Tinkercad, you know, like I said, K through 12. So if one teacher shows them and teaches it, then the next teachers and next grade levels can build upon that knowledge. So lesson plans, you like the lesson plans within Tinkercad. That's wonderful. The merge cube. To be able to understand geometry in a three-dimensional world. Yes. So, you know, with budgets, sometimes in math and art class, even social studies, science, I mean, ELA as well, you want the kids to be able to hold something concrete based on what you're teaching. Tinkercad's going to allow you to do that. Tinkercad's going to allow you to design something, create something, print it, and then create it so that way the kids can hold something substantial that aligns to your standards. So think about it. If you start doing this and you start printing throughout the years, you can have a nice collection of 3D printed objects that you can use along with instruction and pass around the class. I used to teach math before this. I also taught science. A lot of times I wish that I'd had some manipulatives that were, you know, hands-on manipulatives that are expensive if you try to buy them online. Build them in Tinkercad and print them, and then keep them from year to year. It just makes sense instructional wise when you're a teacher and you're teaching the same content area, you know, year to year, to build and create these and print them and have them to allow your students to hold something when you're teaching. I feel overwhelmed. Okay, so I know it's a lot of information. I don't want you to feel overwhelmed, but I'm here for you. I am always available through email throughout the entire school year. So I'm excited to work with individuals from other counties. If you ever have questions, feel free to email me. I will provide that email address at the end of the presentation. I'm always here to help if you have any questions. Okay, so I have a little bit more to show you today, so I'm going to keep moving on. Okay, so let's go into MakerBot Thingiverse. This is going to be quick. I just pretty much want you to see what Thingiverse looks like. Thingiverse, again, is by MakerBot. It's a website. Again, I would not let your students loose on this site, but it enables you as a teacher to go find STL files of different objects that the students may want to use as inspiration. So if you're wanting your students to design a vase, you could bring up this image on your board. You could allow them to see visually an idea, but don't let them copy it. You could actually download this file and extract the STL file from your downloads and then give that to them in Google Classroom, and they could bring it in Thingiverse. And they could use it as a starting point, but you need to make sure that they have to provide a functional improvement to whatever file you give them. So again, Thingiverse is just a database that allows you to build upon and provide ideas for students if they're kind of getting stuck. All right. Let's go into MakerBot Sketch. And I have a question for you before we go into this. Who has MakerBot sketches in their counties or in their classrooms or schools? Has anyone worked with a MakerBot Sketch printer before? No. Okay, Heather says no. I'm not sure about that. We just got some, but I haven't been used yet. Okay, Christine, I'm so glad you told me that you just got one, but you haven't used them yet. I have a full tutorial for you that I'm about to provide you on how to set up a MakerBot Sketch, because that's what we just purchased. We just purchased a lot of those for our county. I have a full tutorial on how to set them up and with pictures, and please feel free to take that with you and use it to set up those printers and to use them. Yes, you are very welcome. Now, what I know of, I've printed a few times on it so far because I had to get to know them well before I start working with teachers. The MakerBot Sketch printers are very, very simple to set up. They're very easy to use. And what I've seen so far, the prints look very nice. So I think it's a good investment. They are kind of small. The build plane is small. You need to keep that in mind. So kids are not going to be able to print something that's a foot long. If they're wanting to create something that's a foot long, they're going to have to create the pieces and print them in chunks and then put them together. And I've seen some teachers do that. You can actually print dinosaur bones and print them in pieces and then have the kids put it together and build the dinosaur. So just know that it doesn't have to be a solid structure that's one item that you print. You can actually print pieces. I've seen some teachers print Lego pieces, and then the kids have Legos to use in their room to create different structures. You can also pause a print. So when you pause a print, it prints a color, and then you can change out the filament and continue the print. And I wanted to explore even changing between regular filament and then malleable filament to have like a hard piece and a soft piece within a design. So all of those things are possible. Okay, so let's look at the MakerBot sketches. Real quick, I'm not going to spend a ton of time on this simply because this is only one type of printer. But you'll see here, this is a MakerBot Sketch 3D printer. Again, it's pretty small. You do get a filament roll with it, but it's only about half of a kilo or a fourth of a kilogram. Typically, when you buy filament, it's in 1 kilogram spools. And so if you want to incorporate some math problems with your students, when you do a MakerBot print preview before you print, it'll tell you how many grams your print is going to take to actually print the product. So your kids could identify out of the class how much filament is going to be used for a class project out of the kilogram of spool. You also need to keep in mind how many grams you're going to allow your kids to utilize within their design, because you could very quickly go through a lot of filament. But 1 kilogram, that's a lot of filament. It's a lot of projects unless you're creating just ginormous designs. With the MakerBot sketches, since it has a smaller build plane, you most likely can get a ton of projects out of one filament roll. So I've just guided you through here how to set it up. With these, I have found that negative 0.7 on the Z-axis is perfect for leveling your build plate. You're going to have to level your build plate so that way your design prints evenly. So set your MakerBot sketch to negative 0.7. I've had success with that. Your extruder is going to get very, very hot. I mean, I'm talking 250, 300 degrees. So you're not going to want to touch it. You're not going to want to reach your hand in there. You're not going to want to let your kids touch this. Also, do not remove your design or your build from your build plate immediately. You need to allow it to cool first. One, it's, if you allow it to cool first, you're not going to get burnt. Two, if you allow it to cool first, the design will pop off the build plate easier, and it will also, you'll be able to remove that raft from the bottom a lot easier. So you're going to need a few tools. I like to cover my build plates with painting tape, the blue, painting tape. It helps just popping things off, but make sure it's on there real even. I also like to have a spatula to pop off designs, and you want to have some tweezers to remove any extra filament from the extruder. And you'll see here that you need to wait for it to load. That's the filament coming out of the extruder. And again, that's very hot. So you're going to want to remove this with tweezers, not your fingers. This is just an example of a test print that MakerBot provides you. This is the actual test print printing. So you'll see your extruder is printing that blue filament onto the build plate. And then here's the final product. You see the raft on the bottom of the actual design. And then it tells you when it's ready to be removed. There's me holding the design with the raft, and then that's where the raft is popped off on the right-hand side. So it does pop off pretty easily. These are settings. And then this is just telling you that you may want to have links to Tinkercad and Thingiverse on your laptop for quick and easy access. A big thing you need to know when using a printer, if you've never used one before, when you use a flash drive or an SD card to transfer your designs from your laptop to your printer, you're going to have to format that SD card or that flash drive before your printer is actually going to be able to read it. So I've got a direction here. You just use your laptop or your desktop, you stick in your flash drive or your SD card, and you go into your folder settings, and you're able to right click on your USB drive and click format. And you want to choose the FAT32 option. That's the file system option. And that's going to make it where your 3D printer can read your flash drive or your SD card. Now, once you format it for the 3D printer, that is made specific. It's going to be specific for that 3D printer. So you need to have a flash drive that's only for your 3D printer. Okay, so I would like you to share your thoughts. And the question is, what is the first project that you would like to implement using the MakerBot sketch? And it does not have to be a MakerBot sketch, because I know everybody is kind of using something different. So share with me here some projects that you are looking forward to implementing in the upcoming year that you're excited about. I see someone has stated design their own cells, illustrating organelles. I think that's great, but again, that's a model. So models are wonderful to have to 3D print, but remember, we're wanting kids to have challenge questions. We're wanting kids to have open-ended problems that they're trying to solve. And the whole goal of this is for them to design something specific to solve a real world problem. So I'm not saying printing models is a bad thing. It's not a bad thing. Sometimes you need models to assist your instruction, to give them something to hold, to understand what you're teaching. But that's separate from having them actually brainstorm and design and create something to solve a problem. Replacement parts for missing game pieces. Yes. And actually, some 3D printers, you can print replacement parts for the 3D printer. Lowell spots, it's actually created with 3D printed parts. And so if a part breaks, you can go in and you can actually print another part for your 3D printer. Like if you had a second one in your classroom, you could go in and do that, which is pretty cool. Tessellations in art class. Okay, that is great idea. Tessellations though, maybe have the kids do a functional improvement to that. How could they alter the shape of the tessellation where it becomes even more intricate to create a specific design in art class? You could have them design something different. Making different types of clouds. That again is going to be a model to have them show that they have learned the content. And I want to lean more towards having them design something to solve a problem with the engineering design process. Okay, thank you for sharing. So we have one more. Let's look at MakerBot Print. And before we get to MakerBot Print, does anyone have any questions? And I'm seeing in the chat here, for science, we've used lessons from this website before to print scans of fossils for students to analyze. That is awesome. Thank you, Jason, for sharing that. I really appreciate it. I love sharing resources. And I'm going to check that out as well and have it for my teachers. Okay, so let's look at MakerBot Print. So MakerBot Print is going to be used if you have a MakerBot 3D printer in your county. MakerBot Print pretty much works with any type of MakerBot printer. There are different versions of MakerBot Print. You want to make sure you have the latest version. But again, this is what MakerBot Print is going to actually slice your design. And again, what that means is take the 2D design out of Tinkercad. It's going to slice it, and it's going to make the file where the 3D printer can read it to then create the 3D print. So it's very important that you have a really good prepping software that you're going to use. I know Cura is one that you can use. It's free. It's web-based. Well, actually, no, Cura is a download. But there's several different types of print preview software, but it's important that you understand how to use it and that you do use it to try to alter your print and preview it beforehand. So with MakerBot Print, you do have to sign in with your Google account. And what it allows you to do is it allows you to see your 3D print prior to actually printing it. So I just went to Thingiverse. I grabbed a starfish STL file. Again, I would not do this in a classroom. I would allow the kids to design first, but I had to do this for the purpose of this tutorial. Now, over on the right-hand side, you have a bunch of different icons, and the bottom icon is your scale option. So you can see you can scale down or enlarge the size of your print. This is going to drastically impact the amount of time and the amount of filament needed to complete a print. So if you only have 20 minutes to print something, it needs to be small. The scale needs to be small. If you've got a full day to print something, you could create something, as long as it fits on your bill plate, that, you know, could take hours. I've had prints run for 8 hours. So this is, your scale would be very large with that type of print. Then your orientation is where your file sits on the build plate. So this is your build plate, and this is what it's actually going to print onto. Again, you can bring in multiple files. I could have a starfish printing, I could have a ball printing, I could have a car printing all at the same time. But if you do that, just understand that you run the risk of, if something happens in the middle of your print and something messes up, it's going to affect all three of those designs instead of just the one. So just know that ahead of time. Then arrange allows you to move it around. So that way you can arrange those objects if you want to print multiple ones at once. The print settings, so you need to pick the type of filament that you're using. If you're going to incorporate supports and bridges, I definitely would incorporate those if you have overhangs or if you have pieces where there's open negative space. Otherwise, your filament's going to droop. Here's some other options with the custom print settings. You've got where you can go into your shells and your infills and add layers. That's going to make your design, stronger. You could make it very flimsy and just put one shell on the outside. That's entirely up to you. And then you've got your print preview icon at the top. And I love this because it does several things for you. First of all, it tells you how much filament is going to be needed to actually complete your print. So this again, you could make it into a math problem for the class. Add up all of the grams of filament that all the projects are going to use to actually print the projects, and see if you have enough filament, see if it surpasses a kilogram. And then it also allows you to see the time estimates, and that's pretty spot on. If it says it's going to take 20 minutes, it takes 20 minutes, and it's going to tell you the exact time when it's finished. You do have to select your printer. So you need to go in and choose the sketch. You can see here the different types of MakerBot printers. We have 5th generations, we have Replicator Plus, we have sketches. So you could use, again, this software with multiple types of MakerBot printers. And then this is to export only the files. MakerBot sketches, you have to use a USB to transfer the file from the laptop to the printer. So this is just showing, yes, you would export that file onto your USB. And then that's just showing your flash drive, and then allow MakerBot print to process. And then again, your final is finished and it's prepared. Okay, Christopher, do you want to go ahead and ask your question chat or unmute your mic?
Yeah, thanks, Rachel.
Sure.
I work with 6th graders and, in social studies. And so I'm really kind of looking, I had an idea that we would make an amusement park.
Oh.
Like using, the ancient civilizations and stuff.
Yes.
Do you think that would be like something that would be a huge project, or?
I think it depends on how many pieces you're planning on printing and the scale of those pieces. But again, if this is going to be a project that you're going to do year after year, you could keep a lot of that and utilize it with the next class. Does that make sense?
Yeah.
So I think you're going to have to determine the scale of the pieces, how many components are to it. But I definitely feel like that is a wonderful project, and I would definitely try it.
All right, cool.
Thank you.
I'm going to reach out to you to help me with that. I'm going to hold you to it.
That's just fine. You can email me anytime.
Cool.
Okay, so I just want to show you this as well. This is very important. So when you've seen your print preview in MakerBot print, and you see that the amount of time and the amount of grams, and you have placed that file on your USB drive, you're going to see that it's now a .MakerBot file. It's no longer a .stl file. So this file is now prepped for the 3D printer. If you still see it says STL, you need to run that file again through MakerBot Print, because the 3D printer is not going to be able to read a .stl. It's going to need a .MakerBot. That may be different for different types of printers. You just need to understand your type of printer and what type of file that it reads. And then always safely remove your USB from your laptop, so that way you don't damage any of the files on your USB. So my question for you now is, why is the vocabulary so important to understand prior to using MakerBot Print? Why do you need to understand what those terms mean? And so I see, so that students and the teacher understand what is what, so students can move the object around space to speak the same language as the technology. Okay, so just like any lesson that you teach, it is imperative that you, as the leader of the class, use the vocabulary that is appropriate to the 3D printing and STEAM and engineering design process. Because when the students hear the appropriate vocabulary, they're going to be able to use it and understand what you're talking about. So it's very important that you call it an extruder. You call the plastic filament. You call it a build plate. You talk about the ask in the plan and the create and the redesign of the engineering design process. Use that vocabulary so the kids start to hear it regularly and they start using it for themselves. There are a ton of careers focused on bringing 3D printing into the profession. My brother actually is one of those individuals. He works for Warner in Asheville, North Carolina. That's where I grew up. And he actually creates prototypes for the company and designs it in Autodesk. There's different Autodesk programs. And then he 3D prints on his major 3D printer. He has to test the prototype, see if it's going to work, and then he sends it off to the heads to let them know that the design is finished. So what you are doing in the classroom with bringing this information in and inspiring these kids, it has purpose. They can go into careers that utilizes this regularly. It opens doors for them. It also teaches them problem solving. It teaches them how to use their creativity. Those two tasks alone feeds into lots of different types of careers. So you're really prepping them for the real world when you're bringing this into your classroom. I have a lot of teachers that I've worked with that are nervous before they incorporate all this new information. I understand. It seems like a lot. After your first project, though, you're going to feel like a pro and you're going to feel more comfortable. You just need somebody to guide you and to help along the way. And you will fall in love with this process because the options are endless. There's so much that can be done with 3D printing and with the engineering design process. So again, if you have any questions, feel free to ask me anytime. So I only have about 6 minutes left. At this time, I have a Padlet. And if you'd like to come on here and share what you've learned today, I would love to hear from you. I like feedback because I like to improve my presentations. I like to improve the content that I'm sharing. Please tell me if there's something that needs to be changed. But I'd love to hear from you here. In addition, here is my contact information. I am on Twitter, and throughout the school year, I do tweet many projects that teachers are utilizing in the classroom. I tweet a lot of resources that I find. so that way others can see them. And I follow a lot of, I try to follow a lot of people. So if you're on there, I would love to connect with you. And my email address is there as well. Please feel free to contact me anytime.